Hello and welcome to this video. In this video, I'm gonna walk through the past paper for Edexcel 2023, paper one. Right, let's get started. So for question one, this is an integration question. Looks quite simple. So let's start by taking out the factor 1/3. So we have 1/3 integral x part 1/2 times 2x minus 5 dx. Then expand the brackets. We have 1/3 outside, and then that will be 2x to the power of 3/2 minus 5x part half dx. That's equal to 1/3 times y. Integrate x part 3/2, so we plus 1 to the power of 5/2 divided by the power of 5/2. And then minus 5 times y, so plus 1 to the power of 3/2 divided by the power of 3/2 plus c. So simplify this, we have 1/3 times y divided by 5/2, that should be 4/5, x part 5/2, minus, so 5 divided by 3/2, that should be 10/3. Then the final expansion will give us the final answer, 4/15, x part 5/2, minus 10/9, x part 3/2 plus c. Okay, let's have a look at another question. So question 2. This is a factor theorem question. Okay, fx is equal to 4x cubed plus 5x squared minus 10x plus 4a, and x is all the real numbers. And then where a is a positive constant, given x minus 1 minus a is a factor of fx. So if x minus a is a factor of fx, so that means x equal to a is the root of fx. So which means fa is equal to 0. And in part A, we want to show that a times 4a squared plus 5a minus 6 equal to 0. Because there's no x in this equation, so that means we have to substitute an a into the function, then we have no x left. So if we do that, so fa equal to 0 will give us 4a cubed plus 5a squared minus 10a plus 4a equal to 0. So 4a cubed plus 5a squared minus 6a equal to 0. So if we factorize the common factor a, then we're left with 4a squared plus 5a minus 6 equal to 0, which is what they required. And then part B. Hence, find the value of a. So now we just have to solve this equation to work out the value of a. So a times by 4a squared plus 5a minus 6 equal to 0. So either a equal to 0 or 4a squared plus 5a minus 6 equal to 0. Then put this into the calculator. So 4a squared plus 5a minus 6. So 4, 5, negative 6. Then we have a is either 3/4 or a is equal to negative 2. And then since at the beginning they said a is a positive constant, so 0 is not a positive number, negative 2 is not a positive number, so 3/4 will be the final answer. And then use algebra to find the exact solution of the equation fx equal to 0. So now we know the value of a, which is 3/4, then we can use that. So fx is now equal to 4x cubed plus 5x squared minus 10x plus 4a. 4 times 3/4 is 3. So that's our fx. And then if we have fx equal to 3, then 4x cubed plus 5x squared minus 10x plus 3 equal to 3. Then 4x cubed plus 5x squared minus 10x equal to 0. Factorize our x, we have 4x squared plus 5x minus 10 equal to 0. So x equal to 0 or 4x squared plus 5x minus 10 equal to 0. Again, put the quadratic into the calculator. So 4, 5, and negative 10. So we have x is equal to negative 5 plus square root of 185 over 8, or x equal to negative 5 minus square root of 185 over 8. And since they want us to leave as exact value, so that will be the final answer. Okay, and then let's have a look at question 3. So question 3 is the vector question. Relative to a fixed origin O, the point A has position vector 5i plus 3j plus 2k, and then point B has position vector 2i plus 4j plus ak, where a is a positive integer. And then in part A, we want to show that OA, the magnitude of OA is equal to square root of 38. Okay, it's only 1 mark, so it's a very simple question. So we know vector OA is equal to 5, 3, 2. And if we're looking for the magnitude of the vector, it basically is the hyperbolas. So square root of 5 squared plus 3 squared plus 2 squared. So 25 plus 9 plus 4, that should be 38. That would be the answer, 38. And then part B, find the smallest value of A for which magnitude of AB is more than magnitude of AA. So let's lay it out. So we want magnitude of OB greater than magnitude of AA. So for vector B, we have 2, 4, and A. So that means the magnitude should be square root of 2 squared plus 4 squared plus A squared. And then that's more than magnitude of OA, which is already known, square root of 38. And then 2 squared is 4, and then 4 squared is 16. So if you add them, that should be square root of 20 plus A squared, more than square root of 38. All right, because they're both inside the square root, so we can just square it for both sides. So 20 plus A squared is more than 38. So that means A squared is more than 18. So solve that inequality. So A should be less than negative square root of 18, or A is more than positive square root of 18. And then since A is a positive integer, so square root of 18 is roughly 4.2426. And then A is a positive integer. So the smallest positive integer, which is more than 4.2426, should be equal to 5. So A is equal to 5 will be the final answer. And then just make sure if someone not sure how to solve the quadratic inequality. So when we have A squared is more than 18. So first we try to find the roots for this equation. So A squared equal to 18, A equal to plus or minus square root of 18. And then because it's a quadratic inequality, we have to sketch the diagram. It should look something like this. And this is root 18, and this is negative square root of 18. So because it's more, so that means it has to be what's above the x-axis. That's why this x is less than negative root 18, or x is more than positive root 18. Okay, let's have a look at question 4. The curve C has equation y equal to fx, where x is the real number, given that the first derivative is equal to 2x plus half cos x, and then the curve has a stationary point with x coordinates alpha. So stationary point, it just means the derivative equal to 0. And then because it says the curve has a stationary point with x coordinates alpha, So that means f dash alpha is equal to 0. So that's the information they try to tell us. And then also alpha is small. And then part A, use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. So small angle approximation for cos, we know cos x is equal to 1 minus x squared over 2. Let me just write it here. So since this is small angle approximation, so we definitely need to use this later. Okay, let's get started. So use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. So we know alpha is a stationary point. That is when the derivative equal to 0. So we can just let the derivative equal to 0. So 2 alpha plus half cos alpha equal to 0. And then 2 alpha plus half of, so cos alpha, because alpha is very small, so cos alpha should be 1 minus alpha squared over 2 equal to 0. So get rid of the fraction. We have 4 alpha plus 1 minus alpha squared over 2 equal to 0. And then times by 2, so 8 alpha plus 2 minus alpha squared equal to 0. So we have alpha squared minus 8 alpha minus 2 equal to 0. So now if we put this into the calculator, 1, negative 8, negative 2, we have alpha is equal to 4 plus 3 root 2. That's roughly 8.2426. And also alpha is equal to 4 minus 3 root 2. 3 decimal places will give us negative 0.243. That's the value of alpha. But be careful. We're using a small angle approximation and they tell us specifically alpha is small. So that means this cannot be our solution because that's not a small value. So not valid. So the only possible solution is just negative 0.243. They have to be careful on that, otherwise we'll lose 1 mark. And then part B, the point P03 lies on C. Find the equation of the tangent to the curve at P, and then give your answer in the form y equals mx plus c. We already have the derivative, f dash x equal to 2x plus half cos x. So the x value is equal to 0. So that means f dash 0 is equal to 2 times 0 is 0, and then half times by cos 0 is 1. So that's just 1/2. So the gradient is equal to 1/2. So it has to be y equal to half x plus c. And then 0, 3. So 3 is a y-intercept. So it has to be half x plus 3. And that will be our solution for this one. Okay. Let's have a look at the next question. Question 5. A continuous curve has equation y equal to fx. The table shows corresponding values of x and y for this curve, where a and b are constants. So that's the table, and then the trapezium rule is used with all the y value in the table to find an approximated area on the curve between 3 and 4. So given that this area is 17.59, and then we want to show the equation a and b. Okay. So we know the trapezium rule formula should be h over 2 times by y0 and plus 2 times y1, y2, and then so on so far, and then plus the y and the last y value. So, and then h should be the gap, the equal gap between each two of the x value. So because the gap between them is just 0.2, so that will be our h value. So substituting into the formula, then the area is 0.2 over 2, and then y0 is the first y value, which is a, and then yn is the last y value, which is 13.5. And then all the rest in the middle we need to multiply by 2. So b2 times 16.8 plus b plus 20.2 plus 18.7. And then close brackets plus 13.5. And they tell us the area is equal to 17.59. Let's simplify this. So 0.2 divided by 2 is 0.1. And then a plus, so 16.8 plus 20.2 plus 18.7 will give us 55.7. Once we have this, it's easier to divide by 0.1 for both sides. So we have a plus 2 times 55.7 plus b plus 13.5 equal to 175.9. Okay. Continue expand the brackets. A plus 2 times 55.7 will be 111.4 plus 2b plus 13.5 equal to 175.9. So a plus 2b is equal to 175.9 minus 111.4 minus 13.5, which gave us 51. And that's the equation they want us to show. And then part B, given also that the sum of all the y values in the table is 97.2, and then we want to find the value of A and value of B. So if the sum of all the y value is 97.2, so A plus 16.8 plus B plus 20.2 plus 18.7 plus 13.5, all this will add up to 97.2. So that means A plus B is equal to, so just use 97.2 minus 16.8 minus 20.2 minus 18.7 and minus 13.5. That's equal to 28. So because there are two unknowns, so that means we definitely have to solve the simultaneous equation. And we already have two equations. A plus 2b is 51 and a plus b is 28. So if we minus this equation, b is equal to 51 minus 28, which is 23. And then a plus b, 23 equal to 28, so a is equal to 5. That's how we find the values of a and b. Okay, let's have a look at next question. Okay, logarithm. A is equal to log base 2x, and then b is log base 2, and then x plus 8. We want to express all the rest in terms of a, or, and b. So first one is log base 2 root x. This one looks very similar to log base 2x, but just instead of x, we have root x. But that's fine. We can change root x into x half 1/2. And then for logarithm rule, we know if you have log base a b to the power of n, you can always bring the power n as the coefficient. So same thing here. We can bring the power of x as a coefficient, which is half times by log base 2x. And then log base 2x is a, so that's just half a. That's how we work out question. And then for question B, we have log base 2x squared plus 8x. So very important thing for logarithm is there's no such rule. Log base ax plus y. So let me write again. So there's no rule for log base a and then x plus y equal to log base ax plus log base ay. So there's no such rule for that. So the only rule for logarithm is only plus 2 logarithm with the same base. You can times the top number x, y. And then when you minus 2 logarithm with the same base, and you can divide 2 top number. That's the only rule we can use. Yeah. So if you see a single logarithm, you can only split them into 2 different terms when there's a product or there's a quotient on the top. Yeah. When you see a sum or difference on top, you can't do anything. You can't split them like that. You have to change into a product or a division. So from here, again, we can't use this. Yeah, we can't split this into 2 logarithms like that. So the only way we can apply this into 2 different terms is we change into a product. And because x squared plus 8x, x is a common factor. So we can factorize our x, then that would be x times x plus 8. And now we have a product. We have x times by x plus 8. So then we can split this into 2 different logarithms using this logarithm rule. So if you have log base ax times by y, you can write as 2 different logarithms plus each other. So we have log base 2x plus log base 2x plus 8. And then we know log base 2x is a, and then log base 2x plus 8 is equal to b. So for part B is just equal to A plus B. And then let's have a look at question C. So we have log base 2 and then 8 plus 64 over x. Again, we can't split this into 2 terms straight away. We have to change into a product or into a division. So the easiest way to start with is just check whether you have a common factor or not. 8 and then 64, that's a common factor, 8. That's what we need to factorize it out. That'll be 8 outside, 1 plus 8 over x. Then we can split this into log base 2, 8 plus log base 2, 1 plus 8x. And log base 2, 8 is just 3 because 2 plus 3 is 8. And then for the second half, there's no common factor we can use. So we have to change into a division in order to apply the logarithm rules. So change into a division means we need to change into one single fraction. So 1 plus 8 over x, you can write this as x over x plus 8 over x. Then they have the same denominator. So now if we add, we have 3 plus log base 2 x plus 8 over x. So log base 2x plus 8 over x is basically log base 2x plus 8 minus log base 2x. So now we have 3 plus log base 2x plus 8 is b. And then log base 2x is a. So 3 plus b minus a is our final answer. Let's have a look at question 7. So this is a function question. And in part A, state the range of f. Because x is more than 2, so when x is equal to 2, 2 minus 2 is equal to 0, and it's the square root, it's always increasing. So that means the smallest possible value for the square root should be equal to 0. And if you plus 3, it should be 3. So that means the range f should be more than 3. And then part B, find f inverse. So to find the inverse function, first we do y equal to 3 plus square root of x minus 2, and we change x into y and then y into x. Now we just have to make y as a subject. Minus 3 for both sides, square it for both sides, plus 2 for both sides. Then we have our inverse function, f inverse x is equal to x minus 3 squared plus 2. And then we know the domain of the inverse function should be the range of the original function. And then the range of f is more than 3. So that means the domain of your inverse function should be x is more than 3. Always remember to put the domain of your inverse function. That's one. Okay, 好，C GF6. Okay, GF6 is same as G of F6. So we need to work out F6 first. So F6 is 3 plus square root of 6 minus 2. That would be 3 plus root 4, which is 2. Then we have G5. And then Gx is 15 over x minus 3. So that would be 15 over 5 minus 3, which is 15 over 2. And that would be the answer. And then part D, find the exact value of the constant a for which fa squared plus 2 is equal to ga. Okay. So we know fx is 3 plus square root of x minus 2. Then fa squared plus 2 should equal to 3 plus square root of, so instead of x, we have a squared plus 2. So then that be a squared plus 2 minus 2 equal to GA, which is 15 over a minus 3. So we have 3 plus square root of a squared equal to 15 over a minus 3. And then square root of a squared is just 15 over a minus 3. And then again, the reason we don't use negative a is because x is more than 2, so it cannot be negative, so we have to use positive a. So times by a minus 3 for both sides. So we have a plus 3 times a minus 3 equal to 15. And that would be a squared minus 9 equal to 15. So a squared is equal to 24. And then a should be equal to plus or minus square root of 24, which is root 4 times root 6, which is 2 6 for a. And then again, a has to be a positive number because whatever the value you input into the f function, x has to be more than 2. So that's why a equal to 2 root 6 is the only solution. Let's have a look at next question. Question 8. So this is the area question. Figure 1 shows the plan view of a stage. The plan view shows 2 congruent triangles ABO and GFO. So that means those 2 triangles are exactly the same. And then angle COE is 2.3 radians. And an arc length CDE is 27.6 meters, which is labeled here. And an AOG is a straight line, and the length is 15 meters. Show that OC is 12 meters. Okay, so let's have a look. So for this one, because we know the angle, and then we know the arc length, and they want us to find OC, basically is the radius of this small sector. So to work out this radius r, we can do 2 pi r times by 2.3 over 2 pi. That's equal to 27.6. So you can use the formula from the formula booklet, but what I normally do is just use the same thing as what we learned in GCSE. So to work out the area, we do pi r square, and if it's a sector, you times by theta over 360 degree, if it's in degree, the units. And then if the units is in radian, I just times by theta over 2 pi. So for the perimeter, 2 pi r is a perimeter, but if it's arc length, If it's degree, you times by theta over surround 60. And if it's in radian, you do 2 pi r times by theta over 2 pi. So just different units, but it's the same concept as what you learned in GCSE. So that's why I just use 2.3 radian divided by 2 pi radian. Then simplify this, 2 pi over 2 pi cancels out. R is just equal to 27.6 divided by 2.3, which is equal to 12 meters. And then part B. Show that the size of angle AOB, which is this angle here, is 0.421 radian, correct to 3 decimal places. Because those two triangles are congruent, that means those two angles should be exactly the same. And if those two angles are the same, and this is a straight line, so you can just use straight line, which is pi minus 2.3 radian divided by 2. Then we can get the answer. So pi minus 2.3 divided by 2, we have 0.420796, but they want 3 decimal places. So we can write as 0.421 radian. Okay, let's have a look at question C. Given that the total length of the front of the stage B, C, D, E, F is 35. Okay, they say B, C, and then D, E, and F. All this in total is 35 meters. Okay, so, and then we already know arc length CDE is 27.6. And again, it's a congruent triangle. So we can just use 35 minus 27.6 divided by 2 to get the length of BC and F. So that should give us, so 35 minus 27.6 divided by 2, we have 3.7 meters. And then we want to work out the total area of the stage. So if AG is 15, that means AO should be 7.5 meters. So we just have to use this area, double it to get all this, and then plus the area of the set to get the total area. Okay. So for triangle, we do half AB sine C. So 7.5 is one of the lengths. And then another length would be BC 3.7 plus CO, which we already work out is 12. And then sine C, we know the angle is 0.421. And then double it would be the area of the two triangles in total. And then we plus the area of the sector of the circle, which is pi r, which is 12 squared, times by 2.3 radian over 2 pi. So put that in the calculator, we have to use the radians as the setting. So 0.5 times 7.5 times by 3.7 plus 12 times by sine 0.421, and then close brackets times 2 plus pi times 12 square times by 2.3 over 2 pi. That's 213.72128 meters square. And they want the nearest square meter. So we can write as 240 meters square. That's what we can find. Okay, let's have a look at another issue. Question 9. This is a geometric series question. Okay. So the first 3 terms of a geometric sequence are 3k plus 4, 12 minus 3k, k plus 16. Show that k satisfy the equation. So because it's a geometric sequence, that means they will have a common ratio. So to work out the common ratio, the second term divided by the first term will give us the common ratio. The third term divided by the second term will also give us the common ratio. So, and then the common ratio has to be the same. So that means 12 minus 3k divided by 3k plus 4 has to be equal to k plus 16 divided by 12 minus 3k. And then cross multiply it. 12 minus 3k squared equal to k plus 16 times by 3k plus 4. Expand it out, 144 minus 72k plus 9k squared. That's equal to 3k squared plus 48k plus 4k plus 64. Simplify this, we have 6k squared, and then negative 72k minus 48k minus 4k, that will be minus 124k. And 144 minus 64, we have 80, equal to 0. Simplify this, divide by 6, we have k squared minus 124. Actually, no, it's not divisible by 6. Let's just put in the calculator. So we have 6 negative 124, and then 80. We have k is either equal to 20 or k is equal to 2 over 3. So there are two possible values. That's for BI. But they said, given that the sequence converges to find the value of k, so that means maybe one of the answer is not correct because the sequence has to be convergent. So for geometric sequence, when it converges, then the common ratio has to be between 1 and negative 1. So the mod of common ratio has to be less than 1. So that's what we need to check. So when k equal to 20, we have the common ratio is 12 minus 3 times 20 over 3 times 20 plus 4. So the common ratio R is equal to 12 minus 60 over 60 plus 4, which is negative 3 over 4. And then when k equal to 2 over 3, we will have 12 minus 3 times 2 over 3 divided by 3 times by 2 over 3 plus 4. Then that's equal to 5 over 3. Clearly, 5 over 3 is more than 1, so it's not valid. Yeah. So it's bigger than 1 and not valid. So this one is smaller than 1, so it's valid. So k is equal to 20. And then find the values of S infinity. Okay. So to sum to infinity, it just the formula is equal to a over 1 minus r. So a is equal to case 20, so we have 3 times 20 plus 4. And then 1 minus r. R is negative 3/4. Put that in the calculator. 64 over 1 minus negative 3/4, which is 256 over 7. That's the final answer. Now let's have a look at question 10. This is a circle question. A circle C has equation x squared plus y squared plus 6kx minus 2ky plus 7 equal to 0, where k is a constant. The part A, find in terms of k, the coordinate, the center, and radius of the circle. Okay, so let's have a look. So x squared plus y squared plus 6kx minus 2ky plus 7 equal to 0. If you want to find the center and radius, you have to change into x minus a squared plus y minus b squared equal to r squared form. So meaning we need to do completing the square. So for this one, first we put all the x together and all the y together. I mean, constant, yes, constant. So completing the square for x, it should be x plus 3k squared minus 9k squared. So we half what's in front of x, which is 3k, and then we square that, which is 9k squared. And then plus y minus half of negative 2k is just negative k squared minus k squared plus 7 equal to 0. So we have x plus 3k squared plus y minus k squared, and then that's equal to 10k squared minus 7. Then we know the center has to be negative 3k and then positive k. The radius has to be square root of 10k squared minus 7. And then for question B, the line with equation y equal to 2x minus 1 intersects C at 2 distinct points. So when you see a line intersect with a circle at 2 distinct points, which means we need to use the discriminant, b squared minus 4ac more than 0. So let's start it. So for part B, we have one line y equal to 2x minus 1, and then the circle x squared plus y squared plus 6kx minus 2ky plus 7 equal to 0. So if we substitute the straight line into the circle, we have x squared plus y is equal to 2x minus 1, and then 6kx minus 2k times by y, which is 2x minus 1, plus 7 equal to 0. So expand it out, we have x squared plus 4x squared minus 4x plus 1, plus 6kx minus 4kx plus 2k plus 7 equal to 0. Then we have 5x squared minus 4x plus 2kx plus 2k plus 8 equal to 0. So now we get this quadratic. So we can still factorize out x for these two terms, because we want one x squared term, one x term, and a constant term. So it will be 5x squared plus 2k minus 4 times x plus 2k plus 8 equal to 0. So now we have this quadratic, and then it's very easy to see which is A, B, and C. So clearly A is equal to 5, B is equal to 2k minus 4, and then C is equal to 2k plus 8. So if we do b squared minus 4ac more than 0, that'll be 2k minus 4 squared minus 4ac. First, I will factorize out 2. That'll be 2 squared times k minus 2 squared minus 4 times 5 times 5, 2k plus 8 more than 0. So 2 squared is 4, so simplify, this comes out. Then expand it out, k squared minus 4k plus 4, and then minus 10k minus 40 more than 0. But you can just expand it straight away. That doesn't matter. This is my kind of habit. So k squared minus 14k and then minus 36 is more than 0. And then once we have this, we just have to solve the inequality. So first, we find we have 1, negative 14, negative 36. And then the roots would be 7 plus root 85. 7 minus square root of 85. And it's a positive quadratic. We know it has to look something like that. So 7 minus root 85, and then 7 plus root 85. And then since it's more than 0, so it has to be this segment and this segment. So k is less than 7 minus root 85, or k is more than 7 plus root 85. That would be the final ones. Let's have a look at another question. Question 10.
in progress.
Okay. The value V pounds of a mobile phone T months after it was bought is modeled by V equal to A times B to the power T. Okay. Yeah, so for modeling questions, we have to be extra careful about the unit things. So V is in pounds, and then T is in months. And then A, B are constants. So figure 2 shows the linear relationship between log base 10V and then T. So the line passes through points 0, 3, 10, and then 2.79 as shown. Use this point to find the initial value of the fund. Okay. So we want to find the initial value of the fund. So like the initial value of the fund is when we want to work out when T equal to 0, what's V equal to basically. And then what we have is this coordinate 0, 3. So this 0, 3 means when T equal to 0, log base 10V is equal to 3. But we're looking for what V is, so we need to rearrange it. So V equal to 10 to the power 3, which is 1,000 pi. That would be the initial value. So 1,000. And then part B, find a complete equation for V in terms of T. And then given the exact value of A and given the value of B, choose 3 significant figures. Okay, so we start from the diagram here. So we have log base 10V is the y-axis, and then clearly it's a straight line. So log base 10V is equal to m, the gradient, which is 2.79 minus 3 over 10 minus 0 times t, and then plus the y-intercept, which is 3. So log base 10V is equal to, simplify that, 2.79 minus 3 over 10 is equal to negative 21 over 1,000. Which is negative 0.021. And then we want V in terms of T. So rearrange it. We have V equal to 10 to the power negative 0.021 T plus 3. So V is equal to 10 to the power 3 times by 10 to the power negative 0.021 T. So that means V equal to 1,000 times by 10 to the power negative 0.021, the power of T. So we have A is equal to 1,000, and then B to 3 significant figures. So 10 the power of negative 0.021 should be equal to 0.95279, but we want 3 significant figures. So V has to be 1,000 times by 0.953 the power of T. That would be the answer for part B. And then part C, exactly 2 years after it was bought, the value of the fund was 320. Use this information to evaluate the reliability of the model. So normally for this type of question, we just have to check what's the value exactly 2 years after it was bought to compare with the value they gave you, 320, to see whether they are close or they are far away from each other. So let's try to work it out. So 2 years. So we have to be careful about the units because T is for months, but this is 2 years. So if we change it into month, that should be 24 months. So that means T is not 2. T is equal to 24. So we have to be careful on that. So when T is equal to 24, V is equal to 1,000 times by 0.953 to the power 24. So if we put that in the calculator, 1,000 times by 0.953 to the power 24 we have 314.941 centimeters bar, which is approximately 315. So that's very close to 320. So you can say it is a reliable model. As 315 is very close to 320. And that's it. Okay, let's have a look at next question. Question 12. Okay, this is the first principle. Let's see. Right, let's have a look. So for first principle, let me just write the formula down in case you need it. F dash x is equal to limits h goes to 0, fx plus h minus fx, and then all over h. So in this case, y is equal to sine x. So fx is equal to sine x. And then fx plus h is obviously sine x plus h. So if we're looking for the derivative f dash x, that would be limits h goes to 0, fx plus h, which is sine x plus h, minus fx, which is sine x, and then all over h. They say without proving, we can use the formula for sine a plus b and also this formula here. Okay, so let's start to use the addition formula for sine first. Sine x plus h is sine x cos h plus cos x sine h minus sine x over h. And then we can see they want cos h minus 1 over h. And then we have a common factor sine x for those two terms. So if we factorize out sine x, we have cos h minus 1, and then plus cos x sine h all over h. And if we split this into two different terms, that will give us sine x times by cos h minus 1 over h plus cos x times by sine h over h. And then they tell us without proof, we can use this sine h over h is equal to 1. And then cos h minus 1 over h, this is equal to 0. So that means this whole term becomes 0 because anything times 0 is 0. And then sine h over h is equal to 1 as h goes to 0. So just cos x left. And which is our final answer. Dy over dx is cos x. And this type of proof is always same. You just have to remember how to remember each step. That's okay. Let's have a look at question 13. On a roller coaster ride, passengers travel in carriages around the track. On the ride, carriages complete multiple circles of the track such that the maximum vertical height 60 meters. That's the maximum vertical height. And then the carriage starts a circuit at a vertical height 2 meters above the ground, and then the ground is horizontal. So the vertical height h is the h meters is above the ground, and then t seconds after the carriage start the first circuit is modeled by the equation h equal to a minus b times t minus 20 squared, where a, b are positive constants. Find a complete equation for the model. Okay. Because we know the maximum vertical height is 60 and it's a quadratic. So that means immediately we know h is equal to 60 minus b times t minus 20 squared. A has to be 60. And then they tell us the vertical height 2 meters above the ground. That's the initial height. So if that's the initial height, that means t equal to 0, h is equal to 2. So we can use that. So substitute in t equal to 0, h equal to 2. We have 2 is equal to 6c minus b times by negative 20 squared. So b is equal to 6c minus 2, which is 58, and then divide by negative 20 squared, which is 400. So b should be 29 over 200. Right. Then we have our complete equation. So h is equal to 60 minus 29 over 200 times t minus 20 squared. Okay, and then for part B, use the model to determine the height of the carriage above the ground when t equal to 40. So substitute in t equal to 40, we have h equal to 6c minus 29 over 200, and then 40 minus 20 squared. So basically, we just put in the calculator. The 6c minus 29 over 200 times by 20 squared, which is equal to 2. So we know the height is equal to 2 as well. And then in an alternative model, the vertical height h meter of a carriage above ground, t seconds after the carriage start the first circuit is given by h equal to 29 cos 90 plus alpha 3 plus beta, where alpha beta constants. And then again, we need to find the complete equation for this alternative model. Okay, so again, we know the maximum height is 60 meters. So cos can only be between 1 and negative 1. So that means in the maximum height, cos has to be equal to 1. So just 29 plus beta is equal to 60. So beta is equal to 31. Then we have h equal to 29 cos 90 plus alpha degree plus 31. And then when t equal to 0, h equal to 2. So substitute in 2 equal to 29 cos alpha and then plus 31. So that means cos alpha has to be equal to negative 1. And then if cos alpha equal to negative 1, alpha is equal to 180 degrees. So the final equation would be h equal to 29 cos 90 plus 180 degree plus 31 outside. Okay, and then part D. So given that the carriage moves continuously for 2 minutes, give a reason why the alternative model would be more appropriate. So because it says on the right, carriages complete multiple circuits of the track. And then this is a quadratic. Quadratic can only be looked like this. And then this is cos, it's a periodic. So that's why if it's periodic, it should be multiple times. But for quadratic, it's not. That's why the alternative model would be more appropriate, because it's a periodic equation. It's periodic. Okay, let's have a look at question 14. Prove use algebra that n plus 1 cubed minus n cubed is odd for all n is natural number. Okay. This is proof by exhaustion. So we want to prove this is always odd for all the natural numbers. And then we can't check all the numbers because there are infinitely many natural numbers. So instead, we check each group of numbers. So we say n is odd, then n is equal to 2k plus 1, so where k is just any natural number. And then We substitute in, we have n plus 1 cubed minus n cubed should be equal to 2k plus 1 plus 1 cubed minus 2k plus 1 cubed. So in that case, we will have actually, so then that would be 2k plus 2 cubed minus 2k plus 1 cubed. So this would be 8k cubed and then plus 3 times by 2k squared times 2 and then plus 3 times by 2k times by 2 squared and then plus 2 to the power 3, which is 8 and then minus 8k cubed and then plus 3 times 2k squared times 1 plus 3 times by 2k and then plus 1 to the power 3 as well. Then we have 8k cubed plus 4k squared and then plus 24k plus 8 minus 8k cubed and then minus 12k squared and then minus 6k minus 1. So simplify that, and this cancels out. Then we have 12k squared plus 18k plus 7, which is same as 12k squared plus 18k plus 6 plus 1. Then factorize up to, we have 6k squared plus 9k plus 3 plus 1, which we know is odd. Because anything comes to is even, and even plus 1 will give us odd. Okay, and then let's have a look at when n is equal to even. Yeah, well, n is even, then n is equal to 2k. So 2k plus 1 cubed minus 2k cubed. So this will be 8k cubed plus 3 times by 2k squared times 3 times plus 3 times by 2k. Plus 1 minus 8k cubed. This cancels out, and that will be 12k squared plus 6k plus 1, which is 2 times by 6k squared plus 3k plus 1. Again, that's odd, so it's always odd. Right, let's have a look at question 15. This is a long question. Okay, so a curve has the equation y equal to fx, where fx equal to 7x e power x over square root of e power 3x minus 2, and the x is more than cube root of t. We want to show that derivative is equal to this. Okay? Let's have a look. So fx is equal to 7x e power x over square root of e to the power 3x minus 2. So to differentiate this is a quotient rule, and use the quotient rule. First, we square the denominator, then that will be just e to the power 3x minus 2. And then we have square root of e to the power 3x minus 2 times by the derivative of the numerator. So differentiate that, that would be 7x times by e to the power x plus 7 times e to the power x. And then plus 7x e to the power x, and then times by the derivative of the denominator. So if you differentiate the denominator, that would be half e to the power 3x minus 2 to the power negative 1/2 times by 3 e to the power 3x. Now we just have to simplify. First, we can multiply by 2 for both sides, both top and bottom. Then we will have 2 times by e to the power 3x minus 2. And then the top will be square root of e to the power 3x minus 2 times by 14x e to the power x plus 14 e to the power x. And then plus this cancels out, the half will cancel out because we multiplied by 2. So it just left with 21x e to the power 4x times by e to the power 3x minus 2 to the power negative 1/2. And then once we have this, we can times by e to the power 3x minus 2 to the power 1/2 for both top and bottom. So if we times that for both sides, then let me write it down. So times by e to the power 3x minus 2 to the power 1/2 for both top and bottom. Then the denominator will become 2 times by e to the power 3x minus 2 to the power 3/2, which is what they want. And then this one times by the same, so that'll be just e to the power 3x minus 2, because half plus half gives 1. And then 14x e to the power x plus 14 e to the power x. And then plus 21x e to the power 4x. So those will cancel out because they are the one is negative 1, another one's positive, negative 1/2, another one's positive. So then we need to write in the same form as they want. So they want 7 e to the power x outside. So we have to factorize our 7 e to the power x. So if we factorize our 7 e to the power x, then we will have e to the power 3x minus 2 times by, so 14 divided by 7 is 2, and the e to the power x factorize out. And then 14 e to the power x divided by 7 e to the power x is 2 left. And then plus 21 divided by 7 is 3, and the x is just x, and the e to the power 4x divided by e to the power x is e to the power 3x. So now we can simplify what's inside the brackets. So we will have e to the power 3x times by 2x plus 2 minus 2 times 2x plus 2 plus 3x times by e to the power 3x. So what I did is I use e to the power 3x times by the brackets to get this. And then I use negative 2 times by 2x plus 2 to get this term. Because we want to get e to the power 3x times by something. So that's why I do this. So once we have this, we can do 7 e to the power x. And then now we have e to the power 3x, e to the power 3x. Factor them out. We have 2x plus 2 plus 3. I think that's a sign error at some point. We never check. Oh, it should be minus since the beginning. It's the quotient rule. Yes, the minus. So this is also minus. This is also minus. And then, so then we will have minus 3x instead. And then minus 4x minus 4 over 2 times e to the power 3x minus 2 to the power 3. So then we have 7 e to the power x, and then e to the power 3x times by 2 minus x minus 4x minus 4 over 2 times by e to the power 3x minus 2 to the power 3. And that will give us the final expression. So A should be -4, and then B is also -4. So 7e to the power x and then e to the power 3x, 2 minus x, minus 4x minus 4 over the same in denominator. Okay, fine. And then let's have a look at part B. The hints show that the x coordinates of the turning point of the curve are the solutions of the equation x equal to 2 e plus 3x minus 4 over e plus 3x plus 4. Okay, so if we want to show that the x coordinate of the turning point, so if it's turning point, we have to let the derivative equal to 0. That's what we need to do here. So let the derivative equal to 0. 7 e to the power x, e to the power 3x times 2 minus x minus 4x minus 4 all over 2 times e to the power 3x minus 2 to the power 3 over 2 equal to 0. So we can't divide by 0, so the denominator can never equal to 0. And then we know e to the power x is always positive. So it cannot be equal to 0. So the only thing we want to solve is just e to the power 3x times 2 minus x minus 4x minus 4 equal to 0. And then we want to show is 2 times e to the power 3x minus 4 over e to the power 3x plus 4. And then we want to make x as a subject. So, okay, let's start to rearrange them. So if we want to rearrange them, let's just expand everything out. So we have 2 e to the power 3x minus x e to the power 3x minus 4x minus 4 equal to 0. So they want 2 e to the power 3x minus 4 on one side. So let's just keep 2 e to the power 3x minus 4 here, and then move another 2 to another side. So then 2 e to the power 3x minus 4 equal to x times by e to the power 3x plus 4. So x is just equal to 2 e to the power 3x minus 4 over e to the power 3x plus 4. And so we get this. So 2 e to the power 3x minus 4 e to the power 3x plus 4. Okay. And then for part C, we want to draw a staircase diagram to show that the iteration formula start with x1 equal to 1 can be used to find an approximation for beta. Okay, so the diagram is in here. Okay, so for this type of question, it's always the same. You start from the value they give, and then you draw a vertical line first, and then the vertical line has to hit the one which is not y equal to x. So the diagonal line is y equal to x. So you always start from the value they give, you draw a vertical line to the other one, not to y equal to x. Then you draw the horizontal line, hit y equal to x. Then you draw the vertical one to another, and then draw the horizontal one to y equal to x, and then so on and so forth. So eventually you can see it will converge to beta. And that's how we solve this question. And then for part D, use the iteration formula with x1 equal to 1 to find to 3 decimal places the value of x2. Okay, xn plus 1 is equal to this. So to find x2, x2 should be equal to 2 e to the power 3x1 minus 4 over e to the power 3x1 plus 4. So you can just do 2 e to the power 3 times 1 minus 4 over e to the power 3 times 1 plus 4. To put that in the calculator. So when we do iteration, first we put x1 into the calculator. So we put 1 in the calculator and then press equal button. And then now the answer key will become the x value. So now we just have to use the answer key now. So we do 2 times by e to the power of 3 times answer minus 4 over e to the power 3 times answer plus 4. So that should give us 1.50177561. And if we want 3 decimal places, it should be 1.502. So that's the value of x2. And then to work out the beta value to 3 decimal places, you just have to keep press the button from the calculator. So x3 is 1.873013103, and then x4 is 1.9570853, and then x5 is 1.966545315, and then x6 is 1.967471265. So far, like if we rounded to 2 decimal places, they will be same. They will all become 1.97. But if we round it to 3 decimal places, x5 will be 1.967. But this one will be 1.967. So they'll be the same. So that means correct to the So you just have to keep press on the calculator until it stops moving. And then for x7, it'll be 1.967560524, and then this is converted to 1.968, and then x8 is 1.967569115, then it's 1.968 as well. So you can see after this value, they all converges to, they all rounded to 1.968. So then 1.968 will be the value for beta. And then part E, use a suitable interval and a suitable function that should be stated, show that alpha is equal to 0.432 to 3 decimal places. Okay, so how do we get alpha? So we get alpha by solving the derivative equal to 0. And then solve the derivative equal to 0 is just same as solve this equation. So that's the equation we should use. And then, so we want to show it's correct to 3 decimal places. So we should use the upper bound and lower bound for 0.432. So for question E, that's the function. And then the upper bound, we should use 0.4325, and the lower bound is 0.4315. And then let's do the substitution. So this would be e to the power 3 times 0.4325, and then 2 minus 0.4325, minus 4 times by 0.4325, minus 4. And then the second one will be e to the power 3 times 0.4315, 2 minus 0.4315, minus 4 times 0.4315, minus 4. So if we put that in the calculator, so the first one should be more than 0. And then the second one should be smaller than 0. Then all you have to say is there's a sign change. And also the derivative function is continuous. And then we can prove it's correct to 3 decimal places. That's it. Okay. That's the whole paper. And I hope you find this paper helpful. Yeah, thank you for watching. And then if you think this is helpful, you can give a like and subscribe to the channel and leave a comment below if you have any questions. I'm always happy to help. Thank you.